Hi, it's Simon, and I'm here to talk to you guys about deriving the moment of inertia for simple shapes. We're going to start with this expression that we should be familiar with for an extended shape. That is the integral over the entire mass of r squared dm. This one. We'll start with a simple thin rod. So the rod has an entire length of big L and is very thin in the y direction and z direction, the other two dimensions. We're interested in the moment of inertia of this rod about an axis through its center of mass. This is denoted by the dotted line shown here. We'll get started by defining a tiny element of this rod, a little dr shown in blue. This dr has a small spatial extent and can be related to a little mass element, dm, that we'll need in order to do the integration. Exactly how the dm and dr are related is through a term lambda, which is the linear density. We'll also use sigma and rho later on for area and volume density, but since this is principally a one-dimensional shape, we can use linear density lambda. Lambda is defined as the change of mass with radius, or spatial extent, so dm over dr. And in this case, if we assume that the rod itself is homogeneous, that means that ratio is constant and equal to the total mass over the total length of the rod. We can rearrange that expression to get an expression for the little mass element, dm. As shown here, dm is then simply lambda times dr. We can now plug this back into our original relationship to have an integral solely in terms of r and other constants. Having made this substitution, we now have to evaluate the limits. We're not integrating over the mass anymore. We're integrating in terms of r. And so our limits of integration will be from the beginning of the rod to the end of the rod, or negative L over 2 to L over 2. Bringing out the constant lambda and evaluating the integral r squared dr yields r cubed over 3 evaluated between negative L over 2 to L over 2. Plugging in those limits, we get m over L for lambda, that's capital M over capital L, times the quantity of L cubed over 24 added to L cubed over 24 because we're subtracting a negative. Simplifying that expression yields the final result, which is 1/12 ml squared. That is, the moment of inertia of a thin rod about an axis through its center of mass, so-called ICM, is equal to 1/12 ml squared. Hope this helps.